Okay, let's go.
I am Gerardo Ferraioli, working for engineering informatica, and thanks for this opportunity for our company. And now we talk about the real-time elaboration with the intelligence application computation. So, let's go. This is our mission. We help our customer in providing solution to design the future and for leading transformation in digital ecosystem. Some word for my company. At a glance, this is the engineering informatica in worldwide. We have more of 11,000 employees, and the very important is we have about 420 data scientists. We are now to talk about the intelligence artificial. In this case, you speak the system that we realized for this element. As you see, we are on site worldwide, and we have about 1 billion of revenue this year and last year. So this is a view as our company is the approach versus the digital transformation. And now we are segmented in 11 pillars. And in this case, I talk about smart transportation, but we have a different market, and on different market we use our solution. For smart transportation, another view, rapid views, is a rapid pitch on our company. We realize the product, and we have product. And the product that I talk about in this session is related to the Diet Suite. It's particularly framework for digital virtual experience. I go on this and focus on smart transportation, and in particular more on infrastructure for rail and roads, airport, port, and so on. This is in our company. We have structured with the competence center cross for all market, and in this case, our competence are related to, and my competence are related to in AI advanced analytics, cross for all market, and particular mode for smart transportation and railway system. It's important in order to that our company is as a system integrator, and we not provide device or product for field, but we use the data coming up for field and correlate, elaborate information, and we apply model, and so we can use the different results on our solution. So, what's happening? For our company, there is, as I said, AI advanced analytics, robot process automation, Internet of Things, real-time, home intelligence, blockchain, digital twin, and so on. Now, let's talk about our capability and our vision on advanced analytics. In this case, the information about advanced analytics is related on left on this picture, but we use the technique, advanced technique for data mining, for example, machine learning, and we have that detail machine learning, pattern matching, forecasting, and so on. This is all elements that we use as a process and modeling with our data scientists in this solution. But A rapid overview of advanced analytics is data management, because data management is very important. Because with the data management, we analyze data. We begin the phase of discovering of elements in these keys. We have the presentation or visualization. When I talk about the visualization or presentation, I talk about the user experience. If you think the Google table, for example, Google table have much more the element, but is very difficult to use in user experience. We rewrite, for example, the element for show more or less 100,000 of event in table, and after we use with a rate of information coming up from a field more or less about 1,000 of events per second presentation in table. And we have a very data scientist and user experience collect that the right code for implementing it. Machine learning. Machine learning, we talk about machine learning for hours. Machine learning, we have the classification, we have the regression, clusterization, whether I have the function continuous or discrete for element. But machine learning is a set of process, and implement machine learning with neural network, for example. After, computer vision. Computer vision is another branch of this area, because with computer vision, we use the convolutional neural network as a part of deep learning. This is an example. The process that used. We have forecasting optimization. When I talk about the forecasting optimization, I talk about the time series, because it's very important that in equation there is the time when the event is coming up from field. Correlate time series. Our solution correlates about 1,000 of time series on node spread, distributed nodes spread on different machines. After this case, we have deployment. Deployment will be able to use the algorithm. When I speak the neural network, for example, there is the learning phase, and in this case is very complicated. Is very CPU consuming, and for example, using in this case GPU element to process in very fast mode the information. Decision support is the natural evolution of this process, and monitoring for all systems. In this picture, I show the paradigm. The paradigm is divided in 3 elements. We have the data. So, as you say, when we speak the data, I speak the analysis of data. But the process is necessary to use the discovering element. When I speak discovering, I saw the predict element, because this is our objective, our goal. And predictive, we use the model, mathematical model. Data mining for discovering part of a large quantity of data. After a forecast optimization, we analyze the trend and what's happening for prevision in the future, and what's happening in this case. After there is the intelligence artificial. When I talk about intelligence artificial, I talk about machine learning, data learning, neural network, recurrent neural network, convolutional, and computer vision. This is the paradigm. To go on manage and execute of system. This paradigm is not implementation, but we use this model to realize the platform and support our client, our customer in solution. So, let's go on next picture. Well, in next picture, we implement the IoT and AI analytics life cycle. In this case, from bottom to up of system, we have first device. And on first device, when I talk about first device, I talk about the equipment, the RQ, the PLC, all produce data. In parallel, in this scenario as a flow data, this is very important because this in parallel is now used by customer and big vendors such as SAS, such as Oracle, and so on. In parallel, we introduce the streaming data. Streaming data is related to the equipment. We have an equipment, we have the streaming data. The data processes in the time. And after, there is a difference rate, and we use, in this case, the Q. In this case, begin to normalize that. The data is going to go up to streaming model execution. This is the core of our system. When I talk about, okay, sorry, I will speed up on this. There is the streaming model execution. Streaming model execution is related information but heterogeneous system. In this case, we use extension and so on. After we have database, when I talk about database, talk about the in-memory database, time series database, and so on. All this process, I apply model based on neural network for to visualization and go on to automatic response, because this is the era when the system is automatically response and action on this element. So, in this case, I go very, this is the core of our platform. So API, publish and subscribe, and so on. But the core is event streaming. For time series, just some word on time series, because our solution with the time series correlate different simulation of different time series. And in this case, we have a performance such as represented in this case with a high solution, 1 major or 1 million the time series correlated between and so on. I very rapid. This is an overview of our solution. In our solution related to railway market, for example, all elements and ATS, front-end, CBCT, and so on, go on step the solution in our platform with the support of advanced analytics. This is technology we use on in our ecosystem, but this is we use as a system integrator all technology and harmonization of all elements. There is also our client, that is impose my marketing show this means. Thanks for